Hello everyone, welcome to this video. In this video, we'll be looking at another question from group theory. Here in this question, they are saying if we take the set of all 2 cross 2 matrices whose entries are being taken from the set of real numbers and whose determinant is +1, we need to show that this forms a group under the matrix multiplication. So here the operation is given to be matrix multiplication. And what is this set? The set consists of all 2 cross 2 matrices whose entries are being taken from the set of real numbers, and when you calculate its determinant, it would be AD minus CB, right, or AD minus BC. This should be exactly equal to 1. So we have a name for this group. If you remember, it was special linear group having all 2 cross 2 matrices whose entries are being taken from the set of real numbers, right? So this is what you have here. Now, in order to show that this forms a group, we need to prove all the group axioms. So what are those? First is the closure property. For the closure property, we take two elements A and B from this set, right? So that then they would be all 2 cross 2 matrices such that their determinants are equal to 1. Correct. Now we wanted to determine whether this AB also belongs to the same set or not. So for that, because all the entries would be your real numbers only, so we only need to check whether that the determinant of this is also equal to 1. But we know that determinant of AB is equal to determinant of A multiplied with determinant of B. Hence both of the determinants, they are equal to 1. Their product is also equal to 1. So this element is also present in the same set. Hence we have this closure property with us. What about the second property, associativity? Associativity property also holds for matrix multiplication. You know that quite well from your lower classes. So we have the second property as well. What about the identity of this group, of this set? So you see we have the identity matrix as the identity here, because the determinant of this matrix is 1 minus 0, which is 1, which is again which satisfies our condition. So this belongs to our group. Right, so third property is also there. What about the inverse? So suppose we take some matrix ABCD, where ABCD, this is a general matrix, general 2 cross 2 matrices, matrix whose entries are ABCD are taken from the set of real numbers, and such that we are taking this determinant AD minus BC as equal to 1, because this is how we select our matrix. Now to find the inverse of this matrix, we have this formula that to find inverse of A, we have the formula that we divided by its determinant and we multiplied it by the adjoint of this matrix. Now what is the adjoint of this matrix? This is the transpose of cofactor matrix. So you just exchange these two, correct, and then you exchange these two with a negative sign, right? And moreover, when you take the transpose, again B would come to this position, C would come to this position. You can check the adjoint would come out to be this one, correct? So this becomes the inverse of this matrix such that its determinant is equal to 1. Hence we have its inverse. Hence we have inverse for all the group members here, all the elements of this particular set. Hence we have a group which forms hence we label this as group, which is a group under matrix multiplication, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.